This is Stat 101, Examples Class 11, Example 1, using a chi-square test for one-way table data. So in our example here, we're testing a claim made by Mars, Incorporated, about the colour percentages of their M&Ms. So what Mars Incorporated claims in terms of M&Ms is that there are, in any packet, we would expect to see 16% of green, 20% orange, 14% yellow, 24% blue, 13% red and 13% brown. That's the claim that we've taken from their webpage. So suppose we want to test this claim by taking a random bag of M&Ms and counting up how many of each colour we see. So suppose we open a random bag and we find 19 green ones, 25 orange, 8 yellow, 27 blue, 13 red and 8 brown. What we're looking at here is, does this sample data support the claim made by Mars? And we're going to test this at the 0.05 significance level, the 0.05 value of alpha. So what we've done here is we've taken those observed values from our sample and we've put them into a column table. So we're looking at the colours. Our observed values came from our sample. To get the expected values, what we need to do is find the proportions of the total made by the claim. So we've got a total of 100 in our sample here, so the expected values would come by taking 16% of 100. So for the green ones, we would have 16%, which is 0.16, multiplied by 100, and that gives us 16 green expected. For the orange, we have 20%, so that's 0.20 multiplied by 100, and that would be 20 orange we would expect. For the yellows, we have 14%, and 0.14 multiplied by 100 gives us 14. For blue, we have 24%, 0.24 multiplied by 100, that would be 24 blue. For reds, we have 13%, so that would be 0.13 multiplied by 100, that is 13. And similarly for brown, 0.13 multiplied by 100, and that would also be 13. Now notice here our expected values will also add up to a total of 100, so we have the same number of observed and expected values. The expected values come by making the calculations from the claim with the same total as we have in our sample. Now, to do a test for this claim, we're going to be using the chi-square test, and this is given by taking the sum of the observed minus expected values, so the difference between observed and expected. We square them to make them all positive, and we divide each of those observed minus expected squared values by the expected value to get the proportional value for each one, and then add them all up, so that's what the sum means. Now we're going to do all of this work in Excel. So we'll move into Excel, where we've taken these values and we've planted them inside of an Excel spreadsheet. So we have observed and expected values in a column the same as in our previous slide. So to find observed minus expected, we're going to use cell references, observed green minus expected value for green, and of course that will give us 19 take away 16, which is 3. So we can scroll down, take that cell and scroll down. It will give us the observed minus expected for the other colours as well. The next thing we need to do is square all of those. So if we take the cell reference for observed minus expected and use the square, then we can see 3 squared is 9, and again copying all of that down the column, each of our square values is calculated for us. And finally, we need to divide each of those cell values by the corresponding value of the expected. So observed minus expected squared divided by the cell for expected, that's C3 there, and that will give us a numerical value for the cell for green. So again, copy that down through the rest of those cells, and we've got all of the individual values for observed minus expected squared divided by expected. So for the chi-square value, we need to take the sum of those. So we take the sum formula, taking down our cells, getting the sum for those. This will give us the value of the chi-square statistic. So we have a chi-square statistic of 6.68 to 2 decimal places. Now, in order to make a decision based on that chi-square statistic, we need to find our critical value for chi-square. Now, Excel allows us to find a critical value for chi-square using exactly the same form as in all the previous ones we've done. CHINV, chi-square. This will ask us for CHINV. Will ask us for an alpha value and a probability. So that's the probability. The alpha value is 0.05. And it will ask us for degrees of freedom. Now, degrees of freedom is a tricky suggestion here. For degrees of freedom for a one-way table is the number of cells take away 1. It's in fact the number of different values you could put in before the final one is fixed. So number of cells minus 1. So in this case we have 6 different colours. 6 take away 1 is 5. Degrees of freedom is 5, and this gives us a critical value of 11.07. So our critical value for chi-square is 11.07. So now let's have a look at doing our chi-square test for the claim. Now recall here that we had a chi-square test statistic, which we'll put in as our evidence. The chi-square test statistic was 11.07. So we'll put that one, 6.68. That was the chi-square test statistic by doing the sum of the observed minus expected squared over expected from Excel. So what is our hypothesis here? What are the hypotheses? We're doing a hypothesis test for the claim. So a chi-square test will tell us that there is evidence. The null hypothesis would be that the proportions are as in the claim. The proportions are as in the claim. So that's what we're saying is the observed values support the expected values. So we can write that as the proportions are as in the claim. And the alternate hypothesis then, if we have evidence to reject the claim, is that the proportions are not as in the claim. So we've got evidence that the claim is incorrect if we can reject the null hypothesis. The alternate hypothesis, the proportions are not as in the claim. Now recall we had an alpha value of 0.05 and degrees of freedom was number of cells minus 1, which was 6 take away 1, which was 5 degrees of freedom. Now if we sketch a chi-square test for the claim, if we sketch the chi-square statistic, if the values were the same in the observed and expected, we'd get a chi-square value of 0. So a chi-square test will always be looking for how far away from 0 is our value. So we're always looking at the right-hand end of the chi-square distribution. So we'll now show 0.05 for the alpha value at the right-hand end of the claim, and that critical value we saw from Excel was 11.07. So the critical value is 11.07, and the test statistic that we're testing here is 6.68. Now remember that the chi-square value starts over here at 0. It looks a little bit like 1 there, so we'll make that look like 0. And that would be if the proportions were identical in the observed and expected. If observed minus expected was 0, then we'd get a chi-square test statistic of 0. So the further away from 0 it is, the more evidence to reject our claim. Now we can see here that our chi-square statistic is not in the rejection region. So our decision would be do not reject the null hypothesis. And this means in our conclusion we can say there is no evidence from our sample that The proportions are not as in the claim. The claim is upheld. No evidence to suggest the claim is incorrect. There's nothing wrong with the claim. Now, one more thing here before we finish this example is another very useful function in Excel, because sometimes we can use, instead of a chi-square test statistic compared with a critical value, we can also use a p-value for the test. And Excel will give us a p-value for this test if we set it up in Excel with our correct shaped observed and expected. We can use the function chi-test, C-H-I-T-E-S-T. This will give us a p-value. Now, if we use chi-test, it asks us always for the actual range, and the actual range will be the observed values for our data. So the observed values for all the different colours of M&Ms. And then it asks us for an expected range, and the expected range will be the values from the claim. That's what we're expecting. Now notice if we use those observed and expected, or actual range and expected range there, it gives us a formula result of 0.245. 0.245 is the p-value for this test. Now, a p-value for the test, if we go back to our template now to think about what that p-value looks like, the p-value for the test is 0.245. And the p-value, of course, null is P is low, null must go. Compared with alpha, a p-value of 0.245 is larger than alpha, which is further evidence that we do not reject. P is low, null must go. So we can also show that p-value on our diagram, because the p-value, of course, is the probability of getting something as unusual as our test statistic, or even more unusual by chance if the null hypothesis is true. So we can shade in that p-value as an area on our chi-square distribution. It's much bigger than the alpha value, and so we do not reject. So that's the end of our example 1, showing you 2 ways of using Excel to get evidence for a chi-square test of a claim. And that's the end of example 1.